Okay, guys, hope you guys are all doing well. I had a couple questions from some of you guys off of these problems from 7.1. So I'm going to go over 11, 13, and 15, and hopefully this helps. So what we have to remember is that we are creating an equation, and the equation has two types of formulas. The first formula is this. Okay, A is your initial value. This is just number one, and R is your rate. Remember, it's a percentage that we want to convert to a decimal. And X stands for time. So this is time. Time can be in years, months, quarters, seconds, whatever time they tell you in the problem, that's where you're going to put your time. And this is for rate increase. So if your amount is going up, this is the formula we would use. For rate decrease, again, A, R, and X mean all the same thing. So a rate decrease is going to equal A, our initial value, 1 minus our rate, and then X is our time. Okay, so these are the ones we're going to use. Let's go ahead and apply this to 11, 13, and 15. So number 11, a baseball card is worth 50 and its value increases at a rate of 23.5 per year. So there's my A value. Increases means we're using 1 plus R formula. And here's my R, but we want to convert it into decimal. So if you recall, we jumped the decimal to the left twice. 1, 2. So my rate is really 0.235. Always has to be in decimal form. And we're doing this per year. So in this problem, we're just setting up the equation. We don't have to solve anything. So for number 11, our equation would look like this. So our rate increase would be equal to A, which is 50, 1 plus R, and our R is 0.235, X. Okay. Clean it up, and the answer to this bad boy is 1.235x, and that's your equation for number 11. Okay, number 12, same idea. Sorry, not 12, 13. Same idea. A plague of mice hit Mr. Kelly's garage, starting with 30 mice. There's our A. They can increase by 650% a month. So it's an increase, and we're doing this 650% a month. This is my R. Okay, but we have to convert it. So our decimal is after the 0, move to the left twice. Once, twice. So once, twice. 6.50 is in decimal form, and let's go ahead and set this up again. So for 13, it's equal to 30. 1 plus R, which is 6.5, And then X, in this case, X stands for month. We can still leave it as X, but it stands for month. As long as you know that, we're good. Clean this up. 1 plus 6.5, that's 7.50. So my final equation is 1 plus 7.50 X. Until they tell us how many months, we really don't have to solve this out. So that's our months there. 15. All right, a 3-bedroom house in Brunsville sold for $190,000. If the housing price is expected to increase 1.8% annually in that town, write an explicit formula that models the price of the house in T years. So 190 is my A, 1.8 is my R, but remember we're going to move the decimal, and that decimal moves to the left twice, and that gives me 0.018, and it's an increase, so we're using the top formula. And then instead of my X, I'm using T for years. So let's set up the model. My A is 190,000. One plus, it's an increase of R 0.018. And instead of X, we're using T for years. Okay. Let's clean this up. Equals 190 1 plus 1.018 T. So that is my formula or my equation. Now let's do the second part. I want to find the price in the house after 5 years. So in essence, we're just going to use 5 and plug it in for T. So let's do that and compute it. So remember, we have to do parentheses first, so we already added. Now we're going to do exponent, so 1.018 to the 5th power. So this gives me 1.093, and then we multiply it by 190,000. So if we do that correctly, we get 207,726. So that is the price after 5 years. Okay, hopefully this helps and clears up some questions.